You're watching Woodlands on the Web, and this is percent composition. So remembering that percent composition is related to percentages, remember that in general terms, percents are a part of a whole. So when we're talking about the composition of a compound, we're going to talk about the grams of an element in that compound divided by the grams of the compound itself, or the sample. And with all percents, we have to multiply by 100%. So that's the general formula for percent composition. And let's add compound or sample. Let's add that. So let's look at a quick example of how we can use percent composition to identify a compound or a substance. So in the first example, our first sample has 28 grams of iron. And we're going to use iron as our determining factor here. The total amount of the sample is 36 grams, as it states. Okay, so if we determine the percent composition of that, we end up with 78%. Okay, if we look over at sample 2, we see that we have 112 grams of iron out of a 160 gram sample. And when we multiply that by 100%, we get 70% even. Okay? So in this particular case, even though the samples are of different sizes, their compositions are different. They have different amounts of iron and oxygen as far as the ratio goes. So these are not the same sample because their percent compositions are different. In this example, we're going to determine the percent composition from the formula of the compound. So for this particular one, we're looking at magnesium nitrate. So first of all, we need to write the formula for magnesium nitrate so that we can make sure that we account for all of the atoms for each element. So we have magnesium, which is again a +2 charge, and nitrate is a -1 charge, so you're going to need 2 of them. So the correct formula is then MgNO32. Okay? So the way that we're going to do this is we're going to start out by finding the molar mass of everything. So because we're talking about part to a whole, if we're trying to find the percent of magnesium, we need to know the molar mass of the entire compound. So remember that we're going to look at the periodic table to find these, and magnesium is 24.31, nitrogen 14.01, okay, but there are 2 of those, so we're going to multiply that by 2. And for oxygen, remember that the 2 on the outside and then the 3 on the inside of the parentheses means that there are 6 total. So you're going to be multiplying 16 by 6. Okay, when you do that math, you end up getting a total of 148.33 grams per mole for magnesium nitrate. Okay, so that's going to be your total or your whole for the percent composition of each element. So when we're looking at just the elements themselves, for magnesium we only have 1 of them, so we just have the molar mass of magnesium divided by the overall molar mass that we just calculated, which is the 148.33. And again, that's for the entire compound. Okay, when we do that and multiply by 100%, then we get 16.39% magnesium. When we look at the second one, because there are 2 nitrogens, the molar mass for the nitrogen is going to be the 14.01 times the 2 atoms that there are, so 28.02 divided by our total mass times 100% gives us 18.89% nitrogen. And by the same logic, we have the 6 times 16 for the molar mass of oxygen, which is where 96 comes from, and 96 divided by our total mass gives us 64.72% oxygen. So with this information, magnesium nitrate as a compound is composed of roughly 16% magnesium, 19% nitrogen, and 65% oxygen. Okay, so that's how you would find the percent composition if given a formula. You can find the percentage of each element within that compound. and that's percent composition.